Hello, everybody. We're about to do an exercise that should help you with your upcoming problem set. In the previous semester, students saw a molecule like this, and they'd never seen one drawn like this, and they kind of freaked out a little bit. Keep in mind that a CH2 in a parentheses is the middle of a chain. CH2s, these, like here's this molecule could be written CH3 with 1, 2, 3, 4 CH2s in a row. Okay, that's a separate molecule here. Get it out of the way. But, there it is. CH2 4 times means CH2, 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 CH2. In this molecule here, Al is 0. I know it seems tricky, but there's really 0 CH2s, which means this carbon is connected to that carbon. That's a bridge size of 2 in this bicyclic structure. M is equal to 3. That bridge size will be, well, it'll go CH2 once, twice, 3 times. So bridge size 3. This bridge size will go CH2, and then because N equals 4, it's going to go CH2 once, twice, 3 times, 4 times 5. So we're up to 5, 6, 7. So we're going to be 2, 3, 7 in our bicyclic molecule. That's supposed to be a dot. Pretty lame, I know. So 2 on the left, 3 in the middle, 1, 2, 3. Doesn't have to be pretty. My dots are not doing so well. And 7. 1, 2, 3, 4, 5, 6, 7. And I'm going to try to make those dots a little better. There we go. So it ain't pretty, but it is the right bicyclic structure. R1, this is R1. It says this is where it's attached. So we're going to have 3 CH2s, 3 CH2s. I'm going to do the wedges and dashes a little later. 3 CH2s, 1, 2, 3. It's a little thick, isn't it? And cut it down. 1, 2, 3. And then we have a carbon that has 2 methyls on it. A carbon with 2 methyls on it. That looks like an iso group to me. Verifying M equals 3, that's 1, 2, 3 CH2s, then a C with 1 H and 2 methyls. R2 is a C that has 2 methyls off of it. That's that, 2 methyls off of that C, and then 4 CH2s off the same carbon. 1, 2, 3, 4. And then a C with 2 more methyls, up to a C with 2 more methyls. Make sure you know that's a carbon. And then a C with 3 methyls. We don't have a common name for that group. We got to use the systematic naming on that group. And just so we're accurate with wedges and dashes, that was a wedge. Make sure it goes all the way. And that was a dash. Make sure it goes all the way. Similarly down here, this is a wedge. And this is the dash. Okay, so we've accomplished step A, which was to redraw the following molecule as a stick figure without parentheses. And now we're about to name it. All right. I'm going to use the area to the left here to name it, which means that little aside is in our way. Okay. This is going to be a multiple line answer. I do know it's a bicyclo. And we're supposed to list the bridge sizes in decreasing order. We had a 7 to the right. And in the middle, there's a 3. And to the left, it's 2. So that's the bicyclo part of the name. And 7 plus 3 plus 2 is 12. 2 more is 14. Tetradecane. That's terrible. Tetradecane. That's just the rings in blue. Groups in green, there's two ways to name groups that have branches. You can use the ISO if it has a pattern, which it does. 1, 2, 3, 4, 5, and a 6th carbon. It's an isohexyl. I'll just write that up there now so we can determine alphabetization. And this one, you have no choice because there's no common patterns, although it's got a tert here, but it's got extras over here. The longest chain for the group starts here. Remember, group numbering is different than chain numbering. The carbon attached to the ring or the chain has to be carbon 1 in the group. So this group has a maximum length of 8. It's an octyl. Don't forget, it's a group. It ends with -il. And it's got a whole bunch of methyls on it. It's got 2 of them on 1, 2 of them on 6, 2 more of them on 7. That's 6 methyls. 1, 1, 6, 6, 7, 7. Hexamethyl. 1, 1, 6, 6, 7, 7. Hexamethyl. Oh boy. Sadly, you can't do that on a test, huh? And now that made that into a B because I'm spatially challenged. Hexamethyloctyl is the name of the group. And it better go in parentheses because these numbers are only for the group, not for the chain. Alphabetizing. This starts with a, not with an H. No, no, no. We don't use prefixes indicating multiples of groups for alphabetizing. For alphabetizing, we use the M for methyl and the I for the iso. Iso going first. So I accept 2 orders for numbering the ring. You can have carbon number 1 of the rings down here. And if you choose that to be 1, you're going to go 2, 3, 4, 5, 6, 7, 8, 9. I'll accept that name, or you can reverse that order starting here 1 through 9, and I will accept it. There's one UPAC rule I don't even enforce, and I'm not even going to mention it. But once again, you can reverse the 1 and the 9 because there's only 2 groups in this molecule. Both methods of nomenclature give a group on 1 and a group on 9. All right, so the isohexyl is on 9. And the other group's on 1. And the other group's name here, I'd prefer not to type it, write out the whole thing again. There's the name of the other group. And there's the name of the molecule. The only thing that remains is our stereocenters. There's a stereocenter on 1 and a stereocenter on 9. Let's get busy. Let's use baby blue. Do the easy stereocenter on 1 first. A carbon with 3 bonds to carbon is number 1. A carbon that hits a branch on the 3rd carbon, 1, 2, 3, is going to be a higher priority than a carbon that hits a branch on the 4th carbon, 1, 2, 3, 4, because you're comparing this 3rd carbon going this way to the 3rd carbon going this way, which is here, 1, 2, 3, and only 1 carbon off that. And this one has 2 more carbons, 3 more carbons off of it total. So yeah, we have 2 here. Once again, I've practiced these a long time. I don't expect you to be this fast. The 4 is over here because there is just a bunch of CH2s and no branch until carbon 9. And where's our 3? It's in the middle here. 1. It has a branch on the 4th carbon. 1, 2, 3, 4. And you were lucky. What do I mean by that? Well, your number 4 group's already on a dash. Means you can connect 1, 2, 3. And that orientation of a circle is clockwise. So 1 is R. And we'll do our other stereo center in pink, not orange. Which one hits, these are all CH2s multiple times. You agree? Yes. Which one hits a branch first? I think it's a tie. 1, 2, 3, and then the fourth one's a branch. 1, 2, 3, then the fourth one's a branch. Why do I like this branched carbon better than this? Well, this one has 2 carbons and an H. This one has nothing but carbons. So eventually you're comparing an H here to a carbon here. So it was close, but we got a 1. Yeah, I'll put it in a square. We got a 1 and a 2. And both of those are wrong because I see the dashed carbon hit a branch much earlier than both of these. Sorry. This hits a branch carbon on the third one. 1, 2, 3. Shame on me. I should have noticed that right away. These hit branch carbon on the fourth one. This doesn't hit a branch carbon until like the 9th one. Oh, and our 4 isn't on a wedge or a dash. Oh, what do we do? What do we do? So the scenarios are, if the 4 is already on a dash, connect your 1, 2, 3, and you have your right answer. A scenario not pictured here, but an equally easy scenario is if the 4 is on a wedge. If the 4 is on a wedge and you're doing a nomenclature question, that's just as easy as if it's on a dash. You connect your 1, 2, 3, and you've got the wrong answer. Switch it. All right. And I don't mean move things, switch it. I mean the wrong answer, right? So just now I got to illustrate with an example because those were just words, and a lot of students don't deal well with words. That's no problem. Everybody's got different learning styles. If you had a stereo center like this, totally unrelated to this molecule, everything below this yellow line is unrelated to our molecule, and you had the 4 happily on a dash, this could be anything. I don't care what 1, 2, 3 are. I'm just telling you right now, when you connect 1, 2, and 3 and it looks clockwise, that's the wrong answer. R equals wrong. Therefore, the right answer is S. There you go. That's a bad looking S. So we're getting more than just problem set practice here. We're getting nomenclature practice. Okay, back to our example. Up here, you don't have either scenario. You don't have the 4 on a wedge or a dash. You have to bite the bullet and do a double switch. Double switches are not hard. Copy all of the bonds in the tetrahedron as you see them. No having trouble with the dash. I'm gonna get rid of everything. The dash is going more up here, isn't it? There. I tried my best to copy everything. I got this here and this here. Those are the 2, and the wedge is here, dash is here. You got to find the 4 and put it where there's a dash bond now. So you put the 4 where the 1 was in this example. 1 used to be there. I need the 4 to be there. And this was where the 4 started. That's where the 1. That's a single switch. Single switch will give you a wrong answer. If you do a switch of the other 2, which is the second or the double switch, you get the right answer. Every time you do a switch, it switches the stereo center. When you're doing nomenclature, you don't want to switch the stereo center. You want to know what the stereo center is. So this is the equivalent of this stereo center, because double switch is the equivalent of the original. And that is a counterclockwise direction. So in orange, we have our final answer. And that's definitely S. And that is the end of this problem. And we're over here. Got a lot on the screen. I will save both of this and the video in the notes for this week. The schedule for this week. Okay, and I hope you found this useful and continue studying for your test.